Good day, Dr. Sabasi. We are a group of students from your course of Digital Modern Communications, and we are going to explain the project or final project of the course. So we have to do a simulation of wireless propagation inside an oil refinery environment. For this, we use a wireless sensor network operating in the 2.4 GHz band. We're going to make a modeling of the radio propagation environment based on a database of measurements. The database consists of 107 links point to point. We are going to check these tables. We have imported the tables here in MATLAB. We have two important tables here. The test parameters point mat and the MF dataset post-processing point mat. Test parameters point mat contains distances, height, number of tests, and pre-classification info for all the tests that we are going to check. The MF dataset post-processing point map contains another important parameters as the average RSS. So what do we have here? To make a little resume, we have the RSS, that is the received signal strength. We have the measurements for 107 point-to-point links, and it's over 15 channels. The channels goes from 11 to 25, and those corresponding to wireless short channels that goes from 1 to 15. We have the frequency is defined, and maybe to check some important parameters. Between these two tables, we have the average RSS. For example, here we have some measurements that we have to check and we have to use. Here we have the 100. We have the 107 levels for the RSS in 15 sequences. As you can see there, we have the 107 and we have the 15 frequencies. For example, in the parameter class, here we have the 107 links point to point. You can see we have some specific values that goes from 1 to 5. We have the Fresnel value. Here we have also 107 registers for every measurement, and we have also the distance, another important parameter, distance 3dm. Here we have 107 registers for the values of the distances. So now let's check what are those values that goes from 1 to 5. Those are the types. The types are different scenarios. That depends of the coverage or depends of the structure. For example, type number 1 is used for LOS. That means a line of sight. We have a clear line of sight. Number 2, type number 2 is for NLOS. That means a no line of sight. Type 3 is for OLOS. It means an obstructed line of sight. The line of sight could have some obstructions inside of the Fresnel area. For the number 4, we have the LOS. Means a near line of sight. It means the LOS have some obstructions around the Fresnel area. And finally, the type 5 is the no line of sight with large obstructing objects. So now we're going to make a little resume of the code that we use here in MATLAB to can develop and find the answers. So we start in defining the variable A that help us to find the type of class that we check. This could go from 1 to 5 to define our scenario. Now the distance type is taken from the parameter distance 3dm of the type. We check these values in the table parameters, and finally here we declare the average RSS type for frequency. This is an arrangement that goes from the average RSS and also depends of the type. So what do we do now is to declare a form, a cycle for. The cycle for is going to help us to find some values for the average RSS type. Now here the project objectives are that considering these models for the RSS of this link, we have to find some optimal values of the model parameters for gamma and alpha, that are the exponential and the power. And we have also the formulas for calculate the value of the RSS. We bring the formula here in MATLAB in this line. The value of gamma that we have for the average RSS. We have the power. We have the value of PO that we declare in the start of the project met final point M. We have here the exponential. The logarithm. The distance type that we defined above. Under the DO. And its power 2. Just like the formula that we check in class. With this for cycle 4, that is defined by the length of the type, and also goes from the length of the value of PO. Also take the value of the exponential 2. So now that we have these calculations, we have to make the matrix. And finally, we make let's calculate for the optimized values. To find the power optimized, that goes for the value of gamma, and the exponential optimized, that goes for the value of alpha in the equation. So we finally make a plot between the distance type and the RSS optimized, and also another plot from the distance type and the average RSS type fault frequency. And this is going to change. We select the type, here we have the 5 types, for example, for number 1. If I run this, I have the values. Number 1 is the type. We are in type 1. That means we are with line of sight. This is the PO optimized and the exponential optimized. Those are the values for gamma and for alpha. And here we have the graph between the RSS optimized and the distance. So we do the same for the type number 2. Here we have the values. Now we do the same for the type 3. Number 4. And for the number 5, we make a little chart with the values to can make a comparison and to check the results for line of sight, no line of sight, structural line of sight, near line of sight, and severe no line of sight. So this is what we have to show about this part of the project with the MATLAB code, the application of the formulas, and finally the results and the graphics. So now, as an optional work, we have to consider that each wireless link is out of service if the RSS value is smaller than minus 90 dBm. So in this case, we're going to use the same formula where the RSS is equal to gamma minus 10 alpha logarithm 10 of the distance divided by the reference distance. So we have to find the maximum supported coverage, that means the maximum distance for each link class. So, well, what we do is take the equation and starting separating the logarithm, applying the properties. This division is converted into a difference between the logarithm of d and the logarithm of d. Then we have to clear the distance, the d. So the reference distance goes to the other side to finally have the division for the 10 alpha and at last we have 10 exponential, the whole value. We have to apply this on MATLAB. So we write this little formula. The value of the RSS, now the variable is RSS2 with the value of minus 90. We declare these variables, put optional 1 and d2 optional 1. d2 is going to be the whole answer, and put optional 1 is going to be the answer for the powered value. So as you know, we have to guide us for the type. For example, for type 1, for type 1 we have the values of the power optimized and the exponential optimized. Power optimized is equal to minus 36 and the exponential optimized is 1.6. So with these values, the values of these variables, we call them in the function. There it is. Power optimized is here, minus 90. The exponential optimized, and the logarithm of dO. dO is the value of the reference distance, there it is, number 3, and divided for 10 exponential optimized, just as we define here in the equation. And for the answers for optional 1, we are going to get the type and the D2 option 1. So if we run this, we will have the value for the type 1. And if we change the type in our project for type 2, we will get gamma of minus 42 and alpha of 2.4. So if we run this formula, we will get the distance, the maximum distance for the type 2. We do the same for type 3. Remember the parameters. Type 3 means obstructed line of sight. Type 3 we get the power optimized or gamma of minus 35 and alpha or exponential optimized of 2.5. So with these values we run again the formula and there is the answer. Type 3, maximum distance 475.468. Now for type 4, minus 35 and 2.3. Type 4, maximum distance 738. And finally, type 5, minus 50 and 2.1. So we have type 5 and maximum distance 204. That's it. So thank you for your attention. I hope you're having a great day.